Last week we discussed the idea of building structure models to identify the objects that we want to track within an organization. So we have a whole bunch of classes that have relationships based on, the interactions that they have with each other. That physical model that we created at the end of last week creates the basis for now creating a relational database. Now, databases come in a lot of different forms, and so we want to take a look at a couple different examples to see how this looks and why relational databases are so common in the way that we conduct business today. We begin by looking at ways that data are stored traditionally. The one that you're most common with is a spreadsheet. A spreadsheet, like something that we see in Excel, is something that we call a flat file, meaning that it's typically one sheet or maybe a couple sheets that are somewhat connected, but they contain just a bunch of data that may be structured or not. Flat files, in addition to being Excel files, can be transferred between computer systems using something called a CSV, or a comma-separated value. Comma-separated values allow us to transfer data between systems without having to go through complicated translation engines. We lose a little bit of fidelity when we use that, but it's a really quick, easy way to get data from one place to the next. So a CSV is really important because it can be used anywhere. In the early days of personal computing, storing data in large tables was very expensive because there wasn't enough storage space or memory to be able to handle those. And so we had to come up with a better, more efficient way of doing that. One of the alternatives that we came up with was something that we call a relational database. So a relational database, instead of dealing with individual flat files, has things called tables. These tables are related together using a primary key foreign key relationship, meaning that I can separate out the data and I don't have to duplicate it quite so frequently. These are also very extensible, meaning that if I have a new data need and I need to collect some more additional information, I can take a foreign key and connect it to a new table using that primary key foreign key relationship, and I can expand it to cover any series of connections that I want. So relational databases became kind of the de facto storage standard in the late 70s and early 80s. Beyond relational databases, as we've moved into e-commerce and we've worked with programming languages and we've come up with more complex systems that allow us to store more things efficiently, and we are no longer limited by the storage capacity of the systems, we have a couple other databases that are also worth mentioning. A common database that we see providing the foundation for many websites and e-commerce sites is something called an object database. An object database focuses on individuals, which we consider objects. If you think about websites, in websites we're creating user directories, and those users have interactions with different objects throughout the website as they participate in e-commerce or microtransactions or so forth. We also see this in e-commerce, where we are using these objects to match customers with shopping carts to checking out and so forth, so we can see that whole progress by making those individual connections. So these are much more efficient for supporting those types of activities. Finally, something that we see with the advent of social media are these things called graph databases. Graph databases are used to connect individual transactions and objects similar to an object database, but at a much more precise level. So these are very common for social media websites, like Facebook and Twitter, where the objects are the tweets or the statuses or the pictures that we're connecting between individuals. And we also move beyond SQL and querying to something called not only SQL or NoSQL, which allows much more robust connections within the data so that we can summarize and get insight into the business. So if you wanted to look at an example of a graph database in a financial accounting setting, think of it more of these are the specific things that are connected. So here I have a sales transaction, and a sales transaction has a positive association with customer number one's accounts receivable. I increase my sales for customer number two's accounts receivables as well. And then these ultimately convert into cash receipts that are connected with those sales. I can also increase my cash by issuing stock and getting paid in capital. So there are a lot of different ways to connect the individual transactions or events in a graph database. that gives you a lot more flexibility in the way that you store the data. We're not going to go into object or graph databases in much depth because we're not dealing with programming these databases. Instead, we're going to be interacting with data that exists in computerized systems for businesses today. Most of those systems, once again, are back here in the relational database area. Since we're talking about relational databases, let's review a couple terms so that when you see them, you'll be familiar with what we're talking about. The first one that we have is something called a database management system, or a DBMS. Database management systems contain all of the data and the structure and the queries and the forms and basically any way that we represent data. So think about software like SAP, which is a large enterprise system, or something smaller scale like Microsoft Access. In Microsoft Access, you are able to create tables where we store the data, relationships. You can also run queries and create forms to input data, as well as prepare reports. So all of these functions take place within a database management system. Our database management system is run by a database administrator, or a DBA. DBAs are responsible for making sure that the data is intact, that it has good integrity, that it's secure, that it has the flexibility for the organization and is containing all the data and good internal controls over that data to protect its security and privacy. Within a database management system, we also have something called a data dictionary. A data dictionary, like you might guess, is something that defines things. So if we look at all of those tables and queries and attributes and so forth, a data dictionary defines the tables, the attributes, the fields, the data types, and so forth. So for example, I may have a table called customer, and inside of that table I have a customer name. That customer name is going to be a varchar. Remember, that's a string that we talked about, so characters. It may be 32 characters long. It may be required. So all the things that describe that data would be defined in our data dictionary. And then the most important element from your perspective is, since you're not going to be designing database systems, you have to know how to interact with them and get the answers that you want, or the summary data, or those transactions, account balances, and so forth to prepare your financial reports. And in order to do that, we need to use something called a structured query language, or SQL, or SQL for short. We use structured query languages for asking questions. Right? Queries are questions. We want to get some summary data from a system. We're going to use it for analysis and also manipulation. We can use it to combine different types of data together to create a summary. So structured query language is the one that you care about and you should pay the most attention to. As you've been working through your labs and learning some of the basics about SQL, you'll remember that the main components of this are we want to select fields from tables where criteria, where we filter it on some sort, or we summarize it on some sort. So this is super important. We want to make sure you've got a good handle on this. This will be on the exam, and we're going to practice this as we go through our next few labs. Now you've got a good handle on different types of databases. We're going to move on to the next step where we're going to talk about the components of a relational database a little bit more in depth.